A year ago, I created this video teaching you how to create a simple third-person character controller for Three.js. But something I didn't anticipate happened. People were lost in the immensity of those worlds. Which way to go? Is there something behind this wall? Is there something after this tunnel? Let's rescue them by adding to the project a lovely minimap following our character. Before starting, if you are new to 3D web development or want to build a solid foundation, consider exploring my course, React 3 Fiber, the ultimate guide to 3D web development. A project-based course with everything you need to know to start creating professional 3D web experiences with Three.js and React. Let's start by cloning the third-person controller project. Link in the description, click on code, copy the URL. In a terminal, git clone, paste the URL, and you can name the folder you want to put it into, R3F Minimap, enter. Once it's done, let's open it, file, open folder, open, and run yarn to install the dependencies and yarn dev to start the development server. Let's follow the link. And we have our project up and running as fresh as it was in the past. What we want to achieve is to put a minimap on the top left or wherever you want to display the scene, but from the top view that will follow our character, and inside we could add additional information, for example, where are quests or enemies. To be able to render another scene without creating a new canvas, we will use the view component from Drei. You have a few examples here and an implementation example in the documentation. How it works is we will have one canvas for our whole page, and then we can create different views, which are div HTML elements. You can size them and position them easily. Based on their position, it will cut the canvas and render the correct scene at the correct place. Let's try to quickly implement it inside our project, first with only the main scene. Let's open the app component. We have our canvas and inside a color and the experience. We have then in the documentation, instead, inside our canvas, we want to use a view from Drei.ports, and then in a separate view, we will put the content of our scene. So it will be the main view. We need to positionate it correctly. So we can use a style and set it to fix and to be full screen. It's what the canvas was before. Here I'm using inline style, but you can use classes, tailwind, whatever you like to style your components. If we try to run it, we will have a blank screen and you will have plenty of errors. This is because the implementation of Vue changed in the recent version. You can see here newer than 8.1. As the project is a bit old, it is not targeting the correct version. Two ways to update the dependencies. Either you do yarn remove or npm uninstall. You type all of them and you reinstall them again. Or yarn upgrade and the different package name, or you are lazy as I am and you copy paste the package.json from a working project, my final project. You save and yarn to reinstall the dependencies and then yarn dev. Let's try again, and our project is running correctly. The difference is we are running it inside a view. Now we can add other views to display other scenes. Let's create our second view. So right after it, here think that the view you are still in the HTML workspace. You are not inside the canvas, but everything that you will put inside your view will be sent using a tunnel inside the canvas. That's why here you can put Three.js element, but the view itself, we are still in HTML container and you can put divs, buttons. So if you need to wrap your view inside a div, no problem, do it the way you like. So I create another view. I copy style, but it will be different here. Let's say a fixed width and height. Space it a bit from the borders and a box shadow to see it properly. Okay, we can see the shadow and the zone where we have our other 3D scene. Note that you won't be able to add border radius. This is because it's still using the main canvas. So if you try to perform things on top of this div, it won't happen. This div, nothing is rendered inside. It's just using its box to know where it is and its size, but it will always be a square. Now inside this, we can try to render a mesh box geometry with a material. Okay, if we reload, we can see that we have this box and the camera is moving also when I'm moving. This is because it's using the same camera that is done globally for the whole project. But as it is separate scene, we can also add another camera. Let's say a perspective camera. Make default. We'll put it in front here. Okay. And now you can see I'm moving, but the camera from the scene on the left is not impacted. Before continuing, if you want to learn more about React 3 Fiber and the views, there is a dedicated lesson in my course in the master chapter, which is views here. In this lesson dedicated to views, we learn how to create different views for this landing page with different parts and different scenes. A link to the course in the description below. Let's get back to the project. What we have is we have a main scene here displaying the 3D model and this animated character. And on the top left, we have an independent scene where we can render 3D elements. To easily connect data from the main scene to the other scene, we will create a global state using Valtio. It's an alternative to Zusten to have a shared store. To install Valtio, yarn add Valtio. And once done, on top of the app, we will create our global store. Of course, separate in separate files for a production-ready project. Here, it's just an experiment. We create a proxy and the data we want inside. We will store three things. The current map to display it also on the minimap. Let's see what are the default values here. Castle on hills, which is the first one. Okay, character position. We create a vector to not recreate ones every time. And the container rotation, which will help us calculate where the character is looking at. Okay, now let's set the values inside experience. If we go here, what we were doing before is using the map from use controls. Instead, we will use the one from our store. So we stop getting it from here, but on change, we will set the value to it. So the value, it will call this function. And game state, this is as easy as it is to change a value with Valtio. So you have your state, the global proxy, and you set the value manually. .map is equal to value. Now in game state, we have the map assigned with the right value. And to have your component re-render with the new value, to not use game state.map, that is not reactive, you do const map is equal to use snapshot of your game state. Now, if map change, it will re-render your component. Let's check if we can still change the map without problem. Seems good, perfect. And now let's try to load this map inside a new minimap component we will create. We won't use the map component to render the model because it's also affected by physics and rigid body. Here we don't need physics for the minimap. So let's do it simply. We go inside the app, and inside the second view, we will create a component named Minimap. Let's create it. New minimap.jsx. Export const minimap. And what we return will be our camera and the mesh. We don't need the mesh, but we will need the main camera. And to render the map, we need to have access to it. Use snapshots of our game state. Now we have the map. And to simply render it, we can use GLTF, the component from Drei. Source is equal to, let's do the same we were doing here. So scale, position, and model. Okay. It's using maps. Is maps exported? No. So now we do it. Again, it's not very well organized. It could be in a separate file. We are taking shortcuts here. Now we can import maps. Awesome. We can go inside the app, import Minimap. But then we have an issue. It's because GLTF is not taking a model, but source. Okay. If we try to load it, we can see we have something loaded here, but we need to add some light. For now, we can add an ambient light with an intensity pretty high at 3. Okay, here it is, but the position of the camera is not at the right place compared to where we are in the game. And also something we can adjust is here, the background is transparent. If we want, inside our view, we can add color, attach background, and then any color within an array. And now here you can see we have our clear color. So our minimap isn't transparent anymore. Let's animate our camera to follow the character. We go to experience. What is controlling our character is character controller. And what we need to do is inside the use frame, after the movement logic, when it will have its final position, we can call character.current.getWorldPosition. And we will do it directly inside GameState.CharacterPosition, which is a vector 3 that will have access to the character world position. We will use it to animate our camera. Now, if we go to Minimap, in a use frame, we have access to the camera in the callback here. This will be the camera from this scene. We can get access to character position. Be careful because character position is a vector. So it's not the object that changed, it's the content of the object. So if we update it in a use frame, it won't retrigger a re-render because it's only the value inside that change. If it wasn't the case, we wouldn't destructurate it to not cause re-render, and we will do GameState.CharacterPosition. You can also do it. But here it's not a problem because only the inside of the object change. So if we have a character position, which should be the case, we will need a vector to define the values. So let's create a dummy one. Temporary vector is equal to new vector 3 to not recreate a new one every time. For our camera position, we will do set character position.x, character position.y plus, let's say 5, and character position.z. And then on the camera, position.copy the temporary vector, but we also need to change where the camera is looking at. To do this, we will look at the character. So we simply set the character position and camera.lookAt temporary vector. Well, we could look directly at character position. Okay, let's see what we get. And now if we move, we can see we have a top view of our scene. But instead of using 5 here hard-coded, we can declare a zoom level. It will be equal to use controls from Leva of Minimap. We can use a lovely emoji for it. Inside the zoom level, minimum to 1, maximum to 30 or whatever you like. And let's set it by default to 12. And now we are using the zoom level here. Okay, now we can see what it gives us at 12. And if we use it, we can zoom in and zoom out. Perfect. It can be difficult to find our way because the camera is not aligned where our camera and character is looking at. Let's add another setting. Autorotate camera. auto rotate camera, by default, we will set it to true. And to be able to rotate the camera accordingly, we created in our game state a container rotation, which is used in the character controller. We just need to copy it. So right after the rotation of the container in the character controller, we can do game state.container rotation is equal to container.current.rotation.y. Perfect. Now, if we go to our minimap, we can do if we have auto rotate camera, the camera.rotation.z will be equal to game state.container rotation. This time it's very important that you use the value from game state, because if you destructurate here container rotation, it will be refreshed at every frame and it will kill your performance. So avoid to do it. Use directly game state dot. And then if it's not the case, camera.rotation.z is equal to 0. Let's try it. We can move. The camera rotates perfectly. And if we want to disable it, it's still following us, but it's not rotating. Depends on what you like. Perfect. But something is missing is we can't see where we are exactly on the map. Let's display our position. For this, I will use a simple image, textures, and I will drag and drop a picture of me. Lovely. Let's load it. Const profile texture equal to use textures of textures/wawa.jpg. Now let's create a group that will contain our image. To render it, we are using a mesh. Because we want to render it on top of everything, we use render order to 1, a circle geometry, and a basic material without depth. So it will also be on top of everything. And profile texture. Then we add another but bigger circle that we will use as a border. It will just be slightly below the other mesh. Because we use render order, it will be below. And then we set its color to red. Let's create our reference here. Const character is equal to useRef. Now we can see there is my picture, but it's not following us. If character.current, we simply set the rotation y to be equal to camera.rotation.z, and we copy its position with the character position. And now if we move, we have our picture here always moving. We could adjust its size if we are more zoomed in or zoomed out, but it depends on what you want to achieve. For a better lighting effect here, instead of just using an ambient light, we could use environment. Much better, much more 3D. But if it's for a real project, you are using it, I guess you won't use the same 3D model with all the different vertices. You might use a simpler version for the minimap. Even maybe not the 3D model, but just the image texture. And let's also try to see if it works on the other maps. Here we are in the Animal Crossing. It's following us nicely. We can go here on top of it. Perfect. On the cities in Tokyo, again, we can see where are the limits where we can go, only from the maps. On the Dust 2, my favorite Counter-Strike map. Excellent. And the best in medieval fantasy book, which is much bigger than the others. And here it can help you find your way. If we zoom out entirely, imagine for a game you could add quests, even path and direction to find where to go. Remember, you have a separate scene. You can add anything you like to add more content to the game. Thank you for watching, I hope you enjoyed this video. Please hit the like button to help this channel be more visible to other creative developers. Don't forget to subscribe to not miss my upcoming tutorials. If you want to continue your 3D web development journey, give a look to my course, link in the description, or watch one of my other videos, like this one, available here.